On this second lesson, we are going to learn how to differentiate the natural logarithms and the exponential function. And here you have the rules. The one that matters the most is actually these two over here, the most generic one, but let's go over these more fundamental functions. So if you have the natural logarithm of x, if you want to differentiate it, that's just going to be 1 over x. If you have the exponential function, if you want to differentiate it, you'll have the exponential function. It doesn't change at all. All right? You don't need to prove this. You just need to use the values in order to solve questions. If you have the natural logarithm of ax, in which a is a constant, if you differentiate it, you will have also 1 over x. There are several different ways for you to think about this. You can think of the natural logarithm of ax as the natural logarithm of a, which is a number, times the natural logarithm of plus the natural logarithm of x. If you differentiate the number, that's just 0. All you have to differentiate then is the natural logarithm of x, which is that, all right? If you have now the e to the power of ax, if you differentiate it, you will have a e to the power of ax. This is explained very easily when we get there. If you have a constant times the natural logarithm of x, differentiating the whole thing, you'll have that constant divided by x. Just apply here the product rule that you learned in the previous lesson, and this is going to be obvious. Same thing goes over here. If you have a constant times e to the power of x, differentiating them, you will have a e to the power of x. If you have the natural logarithm of an expression, and if you want to differentiate that, all you have to do is to differentiate the expression that you have inside the logarithm, and then the result of differentiating the whole thing is this part differentiated over the content itself. We're going to see examples in a bit, but before that, let's see what happens if you need to differentiate e to the power of an expression. Again, just differentiate the expression in terms of x, and the result is going to be that expression times what you have here in the first place. Let's see two examples. The first is about a natural logarithm. You have here 3 natural logarithm of x squared plus 1. So, applying this rule, whatever the constant is, you just keep it there. If you have doubt, just apply the product rule over here. All right? You have 3 times this differentiated plus this differentiated, which is 0, times this. So basically, it's just the first part of what I said. It's 3 times this part differentiated. And what is this part differentiated? Well, look at this expression. Just differentiate this. That's what I did over here. I just called it u, and I then differentiated. And this is obviously 2x, right? So differentiating the natural logarithm of x squared plus 1 is going to be 2x divided by the expression itself, like you can see over here. This multiplied by the 3 is going to be 6x over x squared plus 1. But when you are dealing with this as part of a question, this should be as straightforward as looking at the question and thinking, what is the result of differentiating this? It's going to be 3 times this differentiated divided by this. So 3 times 2x divided by x squared plus 1. You will be able to solve this in what, 2 seconds that I took to do it. There's no big mystery about this. Same thing goes with the exponential. 3e to the power of x squared plus 1. You want to differentiate the whole thing. So it's going to be 3 times this differentiated. And what is this differentiated? Is the outcome of differentiating first the expression, which is just 2x, and then multiplying this by this whole thing without changing it. So it's going to be 3 times 2x times e to the power of x plus 1. Where is it? Here. 3 times 2x is 6x e to the power of x plus 1. right? Here I use the true notation, the true no, I use the full notation to for you to understand more clearly what is going on as you look at these notes. But the process, the mental process that you use is just what I explained. You don't need to put everything like this if you are asked to differentiate something like this. This is just to show how things are done, but the mental process is the one that really matters and what you are going to use anyway in questions.